So, have you ever looked at a complex circuit and just wondered, how does electricity know where to go? How does it split up? It's a great question, and the answer is a really powerful tool for circuit analysis called the current divider rule. And today, we're going to break it down and master it together.
Okay, to really get this, let's use a simple analogy. Imagine the total current, which we're calling I right here, is like a river flowing along. When it gets to a fork, or what we call a junction in electronics, that water has to split. It'll go down both streams, I1 and I2. Now, here's the key. No water just vanishes, right? The total amount is always conserved. It just gets divided up. Current works the exact same way.
All right, before we go any further, there is one single rule that you absolutely have to know for parallel circuits. I like to call it the golden rule, and it's this. The voltage across every single parallel branch is always the same. So V1 is the same as V2, and they're both equal to the total voltage. Burn that into your brain, because it is the foundation for everything else we're about to do. So you might be asking, where do these current divider formulas even come from? Well, they're not magic. They're actually just a really smart shortcut. You see, the long way to solve this would be to first find the total equivalent resistance, then use Ohm's law to find the total voltage, and then use that voltage to find the current in each branch. The current divider rule just wraps all of those steps into one neat, tidy equation to save you a whole lot of time.
And here it is, the shortcut for a simple circuit with just two resistors. Now, you got to look closely at this because it's a little counterintuitive. To find the current in the first branch, I1, you actually use the resistance of the other branch, R2, on top of the fraction. And to find I2, use R1. This is that inverse relationship we're talking about. And it makes sense if you think about it. Current is kind of lazy. It always wants to take the easiest path. So the bigger the resistance in the other path, the more current gets pushed down the path we're measuring.
Now, that two-resistor formula is great. It's quick, but it's also a trap. A lot of people fall into this. What happens when you add a third resistor or a fourth? You absolutely cannot just try to adapt that simple formula. It doesn't work. As you can see here, trying to make it work leads to a total mess. So for anything more than two resistors, we need a bigger, better tool. And this is that tool. This is the general formula, the master key that works for any number of resistors. Now, don't let it scare you. It's actually pretty straightforward. Instead of talking about resistance, which is how much a circuit fights current, we're going to flip it and talk about conductance, which is how easily current flows. Conductance is just 1 over R. So the formula just says that the current in any branch is its share of the total conductance. Simple as that. Okay, that's enough theory. Let's put this into practice with a real-world example. Here we've got an 8-amp source flowing into a junction, and it's got 3 choices: a 4-ohm path, a 5-ohm path, and a really easy 1-ohm path. Our job is to figure out exactly how much current goes down each of those 3 branches using our new general formula. First things first, we need to calculate the denominator of our formula, which is just the total conductance of all the branches added together. So we'll take 1 over 4 plus 1 over 5 plus 1 over 1. Let's make it easy and use decimals. That's 0.25 plus 0.20 plus 1.0. Add all that up, and you get our key number for this problem, 1.45. Remember that number, 1.45. We're going to use it for every branch. All right, let's find the current in branch 1, the one with the 4-ohm resistor. We take its conductance, which was 0.25, and we divide it by our total, 1.45. Then we just multiply that by the total current coming in, which is 8 amps. You punch that into your calculator and boom, 1.379 amps. See? Not so bad. Moving on to the second branch, the 5-ohm resistor. It is the exact same process. We take its conductance, 1 over 5 is 0.20, divide that by our total conductance of 1.45, and multiply the whole thing by 8 amps. And that gives us the current for I2, 1.103 amps. You see the pattern here? It's just rinse and repeat. And now for our last branch, the one with that tiny 1-ohm resistor. Its conductance is just 1 over 1. So it's 1.0. We divide that by 1.45, multiply by 8, and look at that, a whopping 5.517 amps. This is a perfect example of what we were talking about. The path with the least resistance gets the lion's share of the current. It just flows right through there. But hold on, we're not quite done. Any good engineer will tell you to always double-check your work. Let's do a reality check. If we add up the currents we found for all 3 branches, 1.379
plus 1.103 plus 5.517, what do we get? 7.999 amps. That is pretty much exactly our original 8 amps. The tiny difference is just rounding. So yeah, our math is solid, verified. So, to wrap it all up, you now have two powerful tools in your circuit analysis toolbox. If you got a simple case with only 2 resistors, feel free to use that quick and dirty shortcut. But for any circuit with 3 or more parallel resistors, you need to pull out the big gun, the universal formula using conductance. This right here is your cheat sheet. Know when to use the right tool for the job.
All right, theory's great, but practice is where it really sinks in. So now it's your turn. Here's a challenge for you. We have a 5 amp source splitting into 2 paths. One path has a resistance we'll just call R, and the other path has double that resistance, 2R. Can you figure out the currents I1 and I2? Go ahead and pause the explainer, give it a shot, and drop your answers down in the comments. Let's see how you do.
Look, getting comfortable with the current divider rule really just comes down to practice. The more you use it, the more it'll just become second nature. If this guide helped you out, do me a favor and hit that like button and subscribe for more deep dives into tricky topics. Thanks for watching and keep on learning.